Hello everybody, glad to see you again if we've met before, virtually at least. It's Andy Fowler here from Sigma-HSE, doing one of our monthly regular webinars, and the one for today is the top 10 questions we get asked from clients or potential clients when we're having initial discussions about doing some work. So I thought we'd share those to you because I think there's some learning there that we can all take from these sorts of things. So just to start off, just introduce myself really. So I'm currently the Technical and Operations Director for Sigma-HSE, or based over in Winchester in the UK. And my background is I'm a chemist by training and qualification, but I've also done a fair amount of chemical engineering in my time, and a focus primarily throughout my whole career on process safety. So it's been in industry, running major hazard sites with the potential to do a lot of harm, lots of dangerous substances and quite vicious processing conditions. I was also in the UK's Health and Safety Executive as a specialist process safety inspector and risk assessor. So heavily involved in helping clients work with the technical aspects of the likes of the Sigma legislation and DSEAR legislation, have developed risk assessment methodologies and so on and so forth in my time. And you can see some of the guidance that I wrote whilst I was in there. And then for the past 12 or 13 years now, I've been in consultancy, previously with another consultancy in the northwest of England, but then joined Sigma-HSE about 6 months ago now. Sigma, global company, so we've got offices in India and in the UK where the headquarters is, and we've just opened an office in the US over in New Jersey, so we're currently setting that up. So we're an expanding business, and most of you will know that essentially we have three main areas of expertise: process safety consultancy, helping clients deal with the regulatory burdens around the world, doing things properly, whether that's process safety management systems, health and safety management systems, auditing of equipment, helping design. But of course, we also have the luxury of the testing laboratory as well. So we're able to carry out 2 recognised standards, lots of flammability, electrostatics, chemical reaction hazard testing. So coupled with all of those, that experience there and expertise, we're able to deliver that in training courses as well, whether they're open or bespoke to your individual company. So as you'd expect, we've got high technical input from highly qualified engineers and scientists, all of which have spent generally extensive time within the industry and are well known within the industry. We work globally and we work across essentially any of the normal sectors that require process safety, whether that's chemicals, oil and gas, pharmaceutical, but also because of our DSAR expertise, we have a lot of expertise in handling solids and things like that in the food industry and personal care industry. And again, having the luxury of the testing laboratory, and there's not many of those around anymore with the equipment and the expertise to really get to understand the hazards that the industry playing with, that gives us a really nice little niche and that extra expertise. So that's enough of the selling job. So as I said before, essentially I'm just going to pop through the top 10 process safety questions that we get asked and give my opinion on these questions. So you've got some understanding of the way I think, the way the business thinks, and the way the the regulation is set up, especially within the UK, but that carries over into Europe and essentially into the States and elsewhere as well. So the first question, and I've split it down into two really. We know our processes and associated hazards because we've been doing the same thing for years and we've never had an incident. Or similarly, we've been undertaking hazard reviews, process hazard reviews regularly for every so many years. Nothing's changed and we haven't had an incident. Therefore, everything's fine. So what do I think about questions like that? Well, really, when we're looking at identifying hazards, which is the key stage in any risk assessment, you'll be as much aware as I am that when we look at the health and safety legislation around the world, it's all focused around us doing this thing called a risk assessment. And a risk assessment is making decisions on the level of risk that we have within our processes and the tasks that we do, or indeed our everyday life, but we won't go there today. And obviously risk is this combination of the consequences of a hazard, or put it another way, that harm that we could do, and also the likelihood. So therefore, it stands to reason that if we haven't identified a hazard, then really there's no way that we will be able to assess the risks from that hazard because we haven't realised that hazard's there, and therefore we won't have anything built into our processes to prevent, control or mitigate the consequences of that hazard. We won't put in protective devices into our processing plant and so on. The problem is really though, you will know running your processes, you will know that for your desired process, you're pretty well in control. You soon know if you're not, because you start making rubbish product, or the yield alters to where you don't want it to be, or the quality isn't good enough for what you need to be. So, hopefully, if you're generating good product, you're making good things, that obviously tells you that the control of your process is quite good. Otherwise, you'd be making low quality, low yield. You might even make the wrong product or whatever that you can't sell. It'd have an impact on the business. And you do this by making sure that your design keeps within what's called the safe operating envelope. If we don't let the temperature get too high, if we don't let the pressures climb too high, if we control the pH or the concentration, we'll get what we want. But really, when we're dealing with identifying hazards, we've got to give a lot of thought to, well, what happens if we go outside of these conditions? And nothing may happen, or alternatively, something really big may happen. If you consider the Cervezo incident, which many of you will have heard of, that was a chemical reaction which handled relatively benign chemicals. There wasn't any significant great hazard in the reaction that they were undertaking, but it was capable of exothermic runaway. And because they ended up overheating it at some point in the process, they did have an exothermic runaway. But they didn't blow the plant up because there was a vent designed for that. So the vent opened and the contents of the reactor were vented to the atmosphere. What they didn't understand, though, was that the chemistry under those excessive conditions, under exothermic runaway, the chemistry changed. And they started making substances called dioxins. Now, dioxins are very toxic to the environment. So, of course, spraying them all over the surrounding environment around the plant wasn't good. There was a lot of soil had to be dug up, and The meat from the cows and the milk from the cows couldn't be consumed by humans and things like that. But when you consider it, dioxins, one of the hazards that dioxins can have is they can mutate fetuses. Okay, so, and this Seveso is a small town north of Milan in Italy, and the event happened a few decades ago now. But everybody knows Italy's a very Catholic country, very religious Catholic country, and because of this incident, the government, because it was a major incident, so of course it got to the top of government, they started asking questions. The government sanctioned women to have abortions if they required them. Now you can imagine that would not have been an easy decision to make. But it's getting back to the point, it's about, do we really understand what it is that we're doing in our processes? Because obviously, Donald Rumsfeld made the point, you don't know what you don't know. And without having very robust hazard identification techniques, things like hazard and hazard, which many of you be aware of, and apply them properly by using independent, skilled in the art professionals to chair the studies, and having the correct people in the room to answer questions, people who know about the process, know about the chemistry, and then best practice says, as the first question mentioned, you do it all again essentially in 5 years' time. The difficulty is there is an element of familiarity breeds contempt, especially when it's a company practice that says every 5 years we'll do this thing called a process hazard analysis or process hazard review, where we'll have a look. And it's important that we do these reviews, because that's the thing where you might suddenly recognize a hazard which previously you didn't have, you'd missed, because people's brains were getting clouded or whatever. Because we're all humans and we make mistakes, and then you can deal with it. But it's all too easy when you've had a process that has been running for a number of years to go into the PHA already with a closed mind. Well, nothing significant has changed. Any changes that have occurred have gone through our good management of change process. So really, this is just a bureaucratic exercise. Yeah? And you can very quickly cloud your mind and not be as robust and systematic as you should be. For example, I was carrying out an audit in the States some years ago with a manufacturer of organometallic materials. And these organometallic materials are products that they were making don't like water at all, and therefore, they did have fire protection systems, because of course, being an organometallic, they tend to burst into flames pretty easily as well. So if they had a loss of containment, it would ignite and they'd have a fire. And on the vast majority of the processing plant, they had these what looked like large footballs hanging from the roof, and these footballs contained a powdered type of extinguishant. So if there was a fire, these things would fire off and put the fire out, and they were very effective. Okay, but one part of the plant where they were filling product into what I'll call small ISO tanks, 1 or 2 tank pressure vessel, horizontal cylindrical pressure vessels. And they were filling it, but for some reason, in years gone by, that area of the plant was used for something else, but it also had an extinguishant system within it, which was a water-based system. And lo and behold, although they'd were using this part of the plant now to deal with this organometallic product that bursted the flames easily, they still had they hadn't changed over to the water extinguishant to this powder one, and they'd have just made things worse. They'd have had an explosion if that had worked. And yet, you know, being a diligent company, this company did PHAs every 5 years and never really found anything wrong, and never really recognized that this this water-based fire extinguishing system was still there, yeah, and still operational. And in fact, they still paid every 6 months for an outside company to come in and to maintain the system for them. And yet it wasn't picked up with all of these things. So you can see how, you know, technology moves on, the business changes. It really is important. But to me, you know, when you're doing a PHA, the first question that you should be asking yourselves, the team that are going to carry out that study, is if we were building this plant today, how different would it look? Yeah, even though it's been operating safely for the past 30, 40 years, you know, the technology may have changed on. Let me give you an example. Dealing with toxic gases, and especially liquefied toxic gases, it always used to be standard practice, and in fact some of the practices and guidance that's out there still says this is the best way, that for bulk storage of these materials, to keep them out in the open, so they can be readily dispersed and so on and so forth. Okay, but that's no longer what the industry accepts as best practice. Yeah, if you're dealing with these things now, they're generally required to be within some sort of building or enclosure that's got ventilation systems, that's got scrubbers on it, and so on and so forth. So you can get some element of containment instead of spreading, you know, tons and tons potentially of toxic gases around the place. You know, spilling 50 tons of chlorine on the floor in the open goes an awful long way. You're talking of about 20 kilometers, where it's not nice to be in that cloud over that sort of distance. Yeah, so a significant release like that can do a lot of damage. And I've put the last point there, is the basic principle is in process safety, is one of the tenets of process safety. You look at the process safety management guidelines that are out there, published by the Energy Institute in the UK, or the CCPS in the States. You know, they expect companies to be working in continuous improvement mode. What do I mean by that? Not just satisfying the regulations, but constantly seeking to reduce risk, to make things better. Okay, and therefore when you've had a plant that's been running for 30 or 40 years, it's very easy to talk yourself into the thing of nothing's going to happen. For those of you that are operating on coma sites or something like that, and especially if you're up a tier and have to produce a coma safety report where you've quantified those risks, you will have demonstrated to the authorities that the likelihood of these events, these major hazards, are going to be at worst 1 in 10,000 year events, and you've most probably demonstrated that the 1 in 100,000, 1 in a million year events. Yeah, compare that with operating a plant for 30 years. So, you know, applying good, robust, systematic hazard identification and risk assessment protocols regularly, and refresh them and review them, is very important. We shouldn't sit back and just say we're all right, we've not had incidents, therefore it must be safe. Okay, so that's all I'll say about question number 1. We'll move on to the next one. Oh, we've got slips, trips and falls all sorted. So we've not got any problems. Yeah. Now, slips, trips and falls is what's known as occupational safety. It's not process safety, really. Occupational safety is associated with things that generally are low consequence. You know, slipping and tripping, we do all the time. And generally, we pick ourselves up, dust ourselves down and carry on. The harm is extremely low, if anything. Yes, we can still kill people by falling off high roofs or falling through roofs and being knocked down by a Arctic on the travelling around the site and this, that and the rest. So there are serious consequences, but they're generally low numbers. But they are quite high frequency events. We're doing these things all the time. It's part of being humans, you know. Just think of the number of times that you just miss a step, you miss a footing going up or down steps. Nothing happens most of the time. Something bad could happen. You could break your leg. You could, in fact, kill yourself. Yeah, but generally, occupational safety is associated with things like that, and we all know how it's relatively simple to deal with that. There's lots of good practice out there, markings, signings, training of people, personal protective equipment, all of these sorts of things, all very important, all needed under the law. We can all see the reasons for it, but they don't necessarily look at the process hazards. And as I said before in the last question, process hazards generally could be of very high consequence. You know, having explosions and fires and toxic gas releases and things like this. Yeah. But these things happen very rarely. Most of us will not see a major process hazard in our working lifetime. That's the reality of it. Okay. And as I said before, if you've got these significant hazards, you'll have put in many preventative devices and protection devices to reduce the likelihood of these bad things happen. So you're reducing the level of risk to a level that you're satisfied with, because obviously, you know, when it comes down to it, you can't reduce risk to zero, and neither, you know, you've got to balance the cost of reducing that risk. The cost of spending extra money on additional precautions, you know, but the law is written in that way. Okay, but what we're trying to do is prevent this thing happening, and because we're dealing with very infrequent things, it's very easy to push them aside and, you know, I'll deal with that tomorrow or next year, because sometimes it can be a lot more difficult. Some of the tools that we use when we're looking at occupational safety, we also use when we're looking at process safety, like emergency measures and permit to work system and confined spaces. Other tools like HAZOP, like quantified risk assessment, like LOPA's layer of protection analysis and things like this, we could use for occupational safety. We'd be stupid if we did. It's a lot more effort, a lot more costly to a business to do that. The outcome would be the same, but they are what's needed when we're dealing with process safety. Think of it like winning the lotto jackpot. Okay, so in the UK we have a lottery every week, and you can win a few £1 million if you hit the jackpot. Okay, so the consequences of winning that jackpot are quite high, pretty serious, large amounts of money, life-changing amounts of money. Okay, but the likelihood of winning that jackpot is pretty low. Before they changed the rules a few years ago, it was 1 in 14 million. Now, what's that mean, 1 in 14 million? Because it's all right bandying these figures around, but what's it mean in reality? Well, an example of that is if you're a male over 40 and you buy your lottery ticket at noon on Saturday, then you're actually more likely to have died from a heart attack by the time the draw is pulled at 8 p.m. at night than you are of winning that jackpot. And what we're trying to do in the processing industries is not win that jackpot. So we need to put the effort in to not win that jackpot. But thinking about process safety from the point of view of slips, trips and falls just does not work. We've got to focus and understand the process. So we've got to, it's what I call horses for courses. We've got to do the right job and make sure that we don't have these things, because in a sense, occupational safety, failings in occupational safety is not going to wipe your business out. Having large fires, explosions, toxic releases that does a lot of harm is very likely, and has happened in practice over the years with many companies. That's the business finished. Okay, so from a business risk point of view, it's also important not to be thinking that we've got slips, trips and falls covered, therefore we're safe. Question number 3. We've changed our suppliers several times, but it's the same process, so it's safe. Okay, yeah, but is the process the same if you've changed the raw materials, if in any way, shape or form? Yeah, really it isn't, and you should have controls over that. Additional contaminants or slightly different concentrations, things like particle size distribution, moisture content, will have an effect on your process. Whether or not it's a dangerous effect, that all depends. Okay, it depends what you're doing and what can affect the system. But we all generally know that if we're dealing with powders, particle size is important, and generally the smaller the powders, the quicker the reaction, because it's a surface area to volume relationship. It's as simple as that. Moisture content can have an effect on the kinetics and indeed the thermodynamics of a reaction. So there's things associated with the raw material side, the substances that you're using, that if you change suppliers, it needs to go through your management to change process. You need to know whether it will have an effect, and that might mean doing some more additional testing or whatever. But from the other side as well, you've also got to realize that changing any of the inputs, not just your substances that you're using and the form of those substances, but things like batch size, processing temperatures and pressures, feed rates and things like this can all have a significant impact on what happens within those processing systems. Again, we all know the old rule of thumb, 10-degree increase in reaction temperature tends to give us 2 times the reaction rate. Yeah, so that's a significant increase in reaction rate for a relatively small change in processing temperature. And if your system's not designed to cope with that, you can start having problems. So again, scale up. Just go to the just go Google large events that have happened. Go to the chemical, I can't remember the name of them now, but the organization in the States that investigates processing incidents, and look at the number of videos on their website that is associated with runaways and decompositions because of scale up problems, changing batch sizes, running things a little bit hotter or a little bit fuller, or increasing the feed rate to get a little bit more production out. They all have an impact. Number 4, Well, that's all right, because we've got our supplier's material safety data sheet, and that's got all the information we need to be able to run our safe processes. Well, yes and no. Does it really? Does it really? And I'll just give one example here. It's pretty common when you open up most material safety data sheets, especially for solid materials, that you get a common statement of this solid or dust may undergo combustion. Well, how can you design a process using that big piece of information? How can you do it? It's not much help whatsoever. You know, we've got to be a lot cleverer than that. Yes, it may. Most things will undergo combustion. I mean, you know, just like you, I'm a human being. I'm not classified as flammable, but I will burn. I'm combustible. You know, it all depends what we're doing, the size of our ignition sources, and you know, can we fulfill the fire triangle or the explosion pentagon? These are the issues we've got to understand. So, you know, where solids are concerned, it'll be down to things like particle size distribution. It will be down to how readily it can combust, whether it's a KST 1, 2, or 3 powder. And hence, you know, the rate of pressurize is greater as we go through that series. How much energy do we need to put in for the combustion reaction to kick off and for the system to explode or burst into flame? So, you know, that sort of information that you get from a health and safety data sheet doesn't really help you in process design, as well as lots of other things. You know, it's rare, for instance, that you will get dust explosion data, electrostatic data. You know, is it high resistivity or low resistivity, conducting or insulating? What's its thermal stability? Any chemical reaction hazard data. The most you'll get is just a list of things that is considered that are incompatible generally. Okay, and we can't really just use that sort of vague data to help design our processes and make sure that they're safe. Now, in recognition of these failings, there has been some things have been changing at an EU level at least. So the EU Commission regulation, this one that you can see on the slide now, Annex 2 of REACH, and in fact the associated standard, as requires now a lot more data content to be placed into safety data sheets. So you as a user can have some understanding now of, you know, things like chemical reaction hazards, dust explosibility characteristics, electrostatic, you know, whether it can generate charge or whether it's really conductive or whatever, for this sort of data. So this change in regulation and standard came into effect in January of this year. I think there's a year or two transition to get the safety data sheets altered and get the new format of data that's required. So that, you know, you need to be aware of this, because undoubtedly in the UK, the regulator will expect to see changes in the fullness of time and this sort of information to be given. Now, if you go on to our website, www.sigma-hse.com, you'll find we've written down further guidance associated with this. And of course, you can always contact us from the website if you'd like to discuss any of these aspects. Remembering, of course, that we're set up with a testing laboratory. So if you haven't got that data, we can help you obtain that data in the most cost-effective manner, because you know, it's one of these things that needs to be done in the fullness of time. The next question is, we often hear, well, we've got our own fire and explosion awareness training in-house. So, you know, we train our own people in how to be aware of the precautions to take for dealing with fires and explosions and so on and so forth. And again, in some respects, it's pretty similar to question number 1, where we were talking about, you know, well, do you really understand your hazards? Have you got a really good understanding of the things that could go wrong and how big those things could go wrong? You know, it's no good trying to put a dirty great big jet fire out with a fire extinguisher or a water hose. It won't work. So again, whatever we're doing in terms of our training, whether it's firefighting training or evacuation training or whatever, it needs to be specific to what you do and what can happen on your processing plant. Okay, and then you can make sure that you've put in your appropriate mitigation measures to deal with those fires, explosions, toxic gas releases, and so on and so forth that can happen on your site. Yeah, if you have, reiterate again, if you haven't recognized there is a hazard present, you won't have dealt with it in any way, and therefore you won't be able to train it. So when you do train, it's got to be based around, structured around your real processing risks. And don't forget, this is wider than just normal operation of the plant. So you'll also maintain the plant, you'll start it up, you'll shut it down, and so on and so forth, which tends to introduce potentially different hazards that you need to be to deal with if they come about. So it's all got to be essentially done holistically and meshed together to make sure that you can, you know, training people generically, there's not much use when you're dealing with processes, especially processes that can do potentially a lot of harm. We've got to get it specific, and that means we've got to have the information. We've got to know. It's all right knowing, yes, we know it will have a fire, but how big a fire? Because how you deal with a large fire is totally different to how you deal with a small fire. Okay? You may think, some of you may have been on fire extinguishing training, and they'll let you pour water onto a flammable liquid fire. Yeah, or use a fire extinguisher on a flammable liquid fire, and they'll just put about half a litre of petrol or whatever in a, let's say, a little steel tray, maybe a metre square, and let you put the fire out. That's fine. But if one of your bulk tanks loses 50 tons of petrol into the bund and that ignites, that is not the same thing. You know, when you're dealing with half a litre and it's well ventilated, it's a pretty benign fire. When you're dealing with a large bund fire, it's not the same. For those of you who can remember back in the olden days when we used to have coal fires and we used to light a coal fire, or indeed a wood burning stove, and you used to put some kindling in the bottom of the fire with some paper, so readily ignitable stuff, and you'd set that going with a little bit of coal on top. But then you'd cover the front of the fireplace with a sheet of newspaper or whatever, held up with a spade and things like this. And the idea there was to get the draw from the chimney. And that had a big effect on what happened in the fireplace. You had a roaring fire. Okay, and that's exactly what you've got when you start dealing with large flammable liquid fires. If you were to face that fire, you would feel a wind coming from your back as it's drawing in the air from the surroundings to maintain that combustion process. It would be roaring. Okay, and therefore fighting it with a fire extinguisher, you need more than that. Yeah, and they need to be correctly located. The number of times I've been on sites and I've seen fire monitors located around tank farm bunds, and they're supposed to help put out a tank fire when that fire monitor is no more than 2 meters away from the bund wall. If you have a significant fire, you'd be too hot to go and use that fire monitor. Yeah, it needs to be located further away, and therefore it needs to have a bigger pump and all of this to be able to throw the foam or the water or whatever it is you're putting onto the fire the greater distance and all the rest of it. So it really is, we need to understand those hazards before we can really get to grips with making sure that the training that we do is appropriate. Another quite common one is this topic of basis of safety. And just this comment here, the basis of safety of our site is, well, unfortunately, basis of safety is not a site phenomena. Yeah. Basis of safety is a process parameter, and in fact, if you've got a number of pieces of processing equipment, you may have different basis of safety depending on what it is. Yeah, so for a dust collector unit, your basis of safety could be containment, it could be venting, it could be suppression. Okay, but your screw conveyor, it might be something different. Your hammer mill, it may be something different, and so on and so forth. So each operation must be considered in turn, and you get the basis of safety for that. You've also got to look at the interaction between these different pieces of equipment or tasks as well, because they will then allow you to make sure that the basis of safety is correct, is appropriate and justifiable based upon the hazards and the risks that are present within your processing and your processing plant. Okay, because basically the basis of safety, the definition for the basis of safety are the precautions that you build into the process to prevent or mitigate harm from that process. Okay, so of course it's not a site phenomena at all. It's an equipment-based phenomena. Number 7, and we see this very often. We did our DSEAR compliance, we did our DSEAR assessment 2 years ago, therefore we're safe. And it's like everything, it's like taking your car for its annual MOT test. On that day, it's fine. It tells you nothing about what is going to be right for the remainder of the year. Yeah. And of course, as I said before, things change. Yes, if truly nothing has changed, processing equipment hasn't changed, materials haven't changed, your tasks haven't changed, you're just doing the same thing, then it's likely that when you do review it, because under the law, under the Dangerous Substances Explosive Atmosphere regulations, as with everything under the Health and Safety at Work Act in the UK, you need to review. And you may find that that review is, yet nothing has changed. But you've got to be robust, because we may be talking about equipment, the process itself, the way we do things, the substances that we use. And that's on our existing process. You also need to consider if there's new guidance or standards, or the manufacturers have given some new instructions or whatever. So they've changed things that may have an impact. So don't forget, it's very easy to sit around a table and say, well, nothing's changed, therefore we've reviewed it, we're still safe, the assessment is still appropriate and correct. Yet those considerations need to be a lot more robust. Again, I make the point, remember, you're supposed to be seeking continuous improvement. So if you like, you complied on the day that you had your DSEAR assessment done, or you did it yourself, and you found that you complied, that's fine. Yeah, but review and amendment necessary, and that should be linked into, if you have changed stuff, then I'd expect your management to change process to have considered these changes. So when you do review your DSEAR assessment, you should also be looking at what's been happening within your management of change process to pull out the potential changes, because you may then need just to do a slight amendment to the assessment. It wouldn't be a full assessment again, but you may have to review and amend as necessary. Number 8, a classic one, especially when I was an operational health and safety inspector for the health and safety executive. Oh, it's okay, our health and safety manager is responsible for everything to do with safety on the site. Okay, and all I'll do is point you to the Health and Safety at Work Act in 1974, which is still current in the UK and will remain so for evermore, I should think. But that makes it quite clear that health and safety is everyone's responsibility. It's too big a topic for one person to do it all. Yes, you will have a health and safety manager. Yes, their primary task is to make sure that people understand their responsibilities and ensure that improvements are made. So really, you know, if you're acting like this as a business, then there's cultural issues. You know, are you really going to do the proper things, the necessary things under the health and safety law when you're going to put a new process in or change a process or whatever? You're likely not to, because you haven't got that sort of culture. But I mean, this is a question that is asked, still asked, but it's getting rarer. I can remember as an inspector in HSE very often, yes, I'd almost certainly be shown around the site by the health and safety manager. And if I said things needed to be improved, you wouldn't believe how many times health and safety managers asked me, can you give me a notice? Can you give me an improvement notice to get this? Because without that legal bit of paper, my management are not going to make the improvements. I'm not going to get the money to be able to make these improvements. Yeah. So it's a cultural thing. You know, you're not in continuous improvement mode. In fact, you're not even in the alternative, which is regulatory mode, just doing things to satisfy the regulator. If you can't get money out unless there's a stick making the management pay for the improvements that are necessary. Just a couple more to do, and we'll look at DSEAR really for the last couple. We still see this, unfortunately, statements around blanket zoning. So we don't need to do a hazardous area classification because we've blanket zoned. And what that means is we've taken a building or we've taken a room and we've said everything, you know, this whole room is a zone 2. And therefore we've put in appropriate zone 2 equipment and so on if necessary. Okay. It used to be quite common. It's no longer considered best practice, and definitely the regulator doesn't like it. And the reason why the regulator doesn't like it is because it's not specific enough. You know, it's taking the easy way out, and you're basically saying to yourself, this is an easy solution. It's an expensive solution, because if you're doing that, then any equipment, mechanical or electrical or whatever, that could be a potential source of ignition needs to be ATEX protected. So straight away, that equipment is a lot more expensive than standard equipment. And of course, it's got to be maintained throughout its lifetime by specially competent people. So of course, there's additional costs there as well. So the lifetime costs are a lot. So it is an expensive approach, but it doesn't focus down on where you can have these zones and what are, where on your processing equipment within that room you can have your losses of containments and you can generate your flammable atmospheres. So you lose that sort of intelligence by blanket zoning. So, just be aware, it may seem an easier option. You need to be very knowledgeable if the inspector comes calling and you've done blanket zoning, to be able to have that discussion with them, that you do understand you've got all the work behind it, as if you were doing a proper hazardous area classification, but you've taken the decision, which you may do, that it's easier to make the whole room zone 2. Yeah, but you've still got that data behind you. You've still got the specifics of where there might be a zone 1, for example, or a zone 0, and this sort of stuff. So it's like everything else. It's doing the right thing. And the last question, just to finish off. Well, we don't need Sigma-HSE to do any testing because we've got our own laboratories and they can do the testing that's required. Yeah. Now, in reality, most company laboratories focus on quality testing, not the prevention of fires and explosions. Yeah, so the sort of data I've been talking about this morning, understanding whether dusts are combustible and how big the explosion pressure rate of climb is and these sorts of things, and what temperatures they'll ignite at, what energy they'll ignite at, is something really that requires specialized test apparatus and indeed tests carried out to specific standards. So they're expensive pieces of equipment. The vast majority of laboratories out there will not have that sort of equipment. You're more likely just to have perhaps the flashpoint measuring apparatus, okay? But anything outside of that will be few and far between. You've got to have that data though to be able to get to your basis of safety correctly, and so on and so forth, or even if you're using ATEX equipment, to make sure that the categorization of that equipment is correct. So you will need the data, and there's not many places you can in fact get the data done in the UK. I think there's essentially 2 test houses now, open test houses. You might, some of the bigger companies may have the facilities, but they're getting rarer and rarer. And just to make the point, just to finish with, that Sigma-HSE is the only test lab for these tests and apparatus that's used. It's actually accredited to the ISO IEC 17025 quality standard. Okay, so just to summarize then, before we end the day, I think the biggest thing I've been trying to get across today is having this understanding the properties of your materials, understanding what happens in your processes in terms of its hazards is key. We've got to understand the hazards and risks. We've got to make sure that we identify those hazards. We can then put in place the precautionary measures to make sure that we reduce the likelihood of those bad consequences from coming about. So that's all about the front end. Your hazard and risk identification is robust. And if it is robust, you'll have tried to minimize those hazards during your design, and you'll have appropriate level of safeguards installed and be able to demonstrate that those safeguards will be effective and will reduce the level of risk to where the law requires you to be, which is a risk that is as low as reasonably practicable. That's the game that we're in worldwide these days, in one way, shape, form or another. It's all about understanding, putting in place measures, making sure those measures are effective all the time. Okay, so that's all I'd like to say today. Hopefully you'll join us for the next webinar next month, where I think we may be talking about some aspects of chemical reaction hazards assessments, but look out for the emails and the newsletter and so on. As always, if you've got any questions or would like us to help you on any of these things that I've been talking about, then simply either go to the website and fill in the on-site form there, or send us an email to info@sigma-hse.com. Thank you very much for attending. I hope you have a good rest of the week and it's not too taxing at work, and you can enjoy the weekend, and hopefully I'll see you again soon. So thank you very much. Bye bye.